there should be a lot of new information learned from this section. I'll just go over the key components. If you haven't watched these two videos, I would like you to watch them in your own time, and then so we can move on with these questions. So unit circle is the circle with center 0, 0 and the radius of 1 unit. So that's what a unit circle is. And going back to our circle equation, you should be able to come up with this formula because the radius is 1, so it's 1 squared, and the center is 0, 0, so it's just x take 0, y take 0, etc., which just turns into x squared and y squared. Another thing, when we do trig ratios and angles, we go from the positive x-axis, and when there's a positive, we go that direction, and when it's a negative, we go that direction. So the theta is positive for anti-clockwise rotations and negative for clockwise rotation. And for example, if we have an angle of 210 degrees, we can change it to radians by timesing it by pi over 180. So we did that in a different chapter, so you should be able to do that now. Again, same thing, you times it by pi over 180 degrees. And as you can see that these are positive angles, so you go that way 210 degrees, and then minus angle you go that way, which is a minus 150 degrees, etc. Some definitions of sine and cosine. So if we look at this right angle triangle and start to look at this unit circle, so the hypotenuse is 1, you can rearrange equations to find your a, x and y coordinates, also known as a and b in this case. We can actually redefine these as cos theta and sine theta because of using the trig ratios. So cos theta just becomes the x coordinate of a unit circle now, and the sine theta becomes the y coordinate. Obviously, that coordinate will depend on what that angle is. So in our case, it's a theta. If it's, let's say, 90 degrees, you put a 90 in there. If it's a 180 degrees, you put 180 in there, etc. It could be degrees or it can be radians, depending on your calculator setting. So wherever it is, you can just plug in and find your coordinates of x and y, as long as you know the angle. So using that cos squared theta, using the x squared plus y squared equals 1 equation, the unit circle equation, we can substitute because x is cos, so x squared is the same as cos squared, and then a little fact that we write the squared in front of the theta, just after the cos, not at the end of it, like so. And your y coordinate, your sine theta squared equals 1. So this is a new trig ratio we can kind of use that's basically got derived from the equation of the circle. And another thing we can notice is that we have a bit of a range. We got that x coordinate has to be between minus and 1 because it's a unit circle. Our radius of the circle is going to be greater than 1. So it's going to be -1 from 1 for your x coordinate as well as your y coordinate. Now tangent, what is a tangent? Tangent is simply a ratio between sine and cos. So what that means is a gradient in our case. So ratio between your x and y coordinates. So it actually shows this gradient, what gradient it is. Is it a positive, is it a negative, etc., and what sort of degree it has. Something you might have also learned is this acronym that we use. I use South Australian Tennis Club, which is a little bit of a different order, but what you might want to use is All Silly Turtles Crawl, because then you are used to using going in the same order as the first, second, third, and fourth quadrant. So you go All Silly Turtles Crawl. So try to remember the acronym, and it might help you remember which one's positive in which quadrant. So for example, your sine, cos, and tan are all positive in quadrant 1 over here, so it's the all, everything's positive, and only sine is positive in the quadrant 2, so only s is positive, so that's why it has an s. Only tan is positive in quadrant 3, so that's why it only has a t. T is the only positive one, and the only one positive in the fourth quadrant is cos, so that's why it has a c. So everything else, if it's not positive, obviously it's going to be just having a negative value. And it's easy to follow if you have a look at what the x coordinates would be. Would it be a positive x coordinate or a negative x coordinate? If you just have a think about it, it shouldn't be too hard to figure that out either. So what you need to do in example 6 is use a unit circle diagram to find the values of cos minus 270 degrees and sine. So we'll give that a go. So we draw a unit circle, and you got to go minus 270 degrees. So you start from your x coordinate, which is basically a 0. And I'm not going positive direction. Remember, that's positive direction. That's negative direction. I want to go minus 270 degrees. We know that this is 90 degrees. So if I start from over here, that's 90 degrees, minus 90 degrees. Another minus 90 degrees, so I'm at minus 180, and then I have to go another minus 90 degrees, which becomes minus, so this whole angle, if I draw a little angle, if I go from here to here, that is minus 270 degrees. So all I need to do is find the cos, which is the x coordinate. Remember that it's the cos theta sine theta. All I have to do is find the x coordinate of the y coordinate of that unit circle. It should be pretty easy to find using the unit circle, and you don't have to chuck that in the calculator at all. But if you do, you should still get the answer. But this question is asking you to kind of think about it mentally. So we know that it's going to be at this point over here. How to think about it? What is going to be my x coordinate? Well, it's a unit circle, so it's going to be 0. My x is under 0, but my y coordinate is going to be 1 unit away because that radius of the circle is 1. So simply, my cos theta is going to be 0, or in this case, I should write my cos theta is minus 270, and then my sine theta is minus 270. If I write it like so, therefore my cos minus 270 degrees would be 0. And my sine minus 270 degrees would be 1. And if you just write it on your calculator, you should be able to just double check that as well. Just make sure your calculator is in degrees because we're using degrees, not radians. So that's how, if you're sometimes using radians, which is units of pies, you might want to change it back to radians. If not, you can use degrees, depending on what you're given.